Hi, welcome to my channel. In this video, I'll show you how you can make a simple 2000 watts inverter based on the TL494 CD IC and the IRF1404 power MOSFET. The circuit is shown. At the input you have your 12 volts from a battery. There's a decoupling capacitor. The TL494 needs to be configured as a push-pull driver, and this is done by pulling the output control pin 13 to 5 volts at pin 14. The output transistors will be switching on and off as complementaries of each other, and they are pull-up resistors of 220 ohms and rated at least 1 watt each. The error amplifiers need also to be disabled, and this is done by pulling down the non-inverting terminals pin 1 and 16 to ground through this 10 kilo ohms resistor, and pulling up the inverting terminals to 5 volts through this 51 kilo ohms resistor connected to pin 14. The frequency is set by the value of the capacitor C1 and the resistor R1. The formula is given by 1 over 2RTCT, and with the parameters as 100 kilo ohms and 100 nanofarads. The frequency will be 50 Hz. For 60 Hz, just change C1 to about 82 nanofarads. You also need to pull down the 10 time control pin to ground through a 10 kilo ohms resistor to ensure that the output duty cycle is maximum. The way it works is that the output transistors will be working as complementaries of each other. When the first one is on, the other one is off, and vice versa. Assuming at the beginning the first transistor is off, so there will be a high pass at the open collector of pin 8, and so the MOSFETs Q1 and Q2 will conduct. The Zener diodes D1 and D2 as well as D3 and D4 ensure that the gate source voltage does not exceed 12 volts, which is recommended for most MOSFETs. When the MOSFETs Q1 and Q2 conduct, current will flow from VCC through the left hand side of the primary winding through the MOSFETs and to ground. When the first transistor turns on and the second transistor turns off, the MOSFETs Q1 and Q2 will turn off, but the MOSFETs Q3 and Q4 will turn on because there will be a high at this point, and so current will flow from VCC through the right hand side of the primary winding through the MOSFETs and to ground. The capacitor C3 and resistor R8 as well as the capacitor C4 and resistor R9 ensure that any voltage spikes generated across the entire primary winding, they are shortened together so as not to damage the MOSFETs. The IRF1404 power MOSFETs can easily handle about 150 amperes, so if you parallel two of them, you can easily handle more than 300 amperes, which is more than enough to have a capacity of 2000 watts at 12 volts. Although you can power it 24 volts, just ensure that you have a regulator to supply 12 volts to the TL494. For the transformer, you can salvage one from a microwave or a welding machine. Ensure that the coil is large enough to support 2000 watts or any other wattage you desire. I recommend you mount the IRF1404 power MOSFETs on good sized heat sinks. For the turns ratio, they should be 1:20. I mean that you should have 10 turns on each side as an example and 20 turns on the other side for the output so as to get 240 volts AC. The PCB I have developed for the project is as shown. Here you have your input. This is the IC and its mandatory biasing components. These are the MOSFETs on each side, and here is where your transformer goes. This is the center tap, and pin 3 and pin 1 at the end of the primary windings. The blue tracks are the bottom copper and the red tracks are the top copper. In 3D, the board looks as shown. Thanks for watching. I hope you liked this video, and if so, make sure to like, comment, share and subscribe to my channel for more amazing tutorials and projects, and I'll see you in my next episode. Have a nice time.